Hi guys, today we're going to look at differentiating E. Now E is a function. It's a function like sine, cosine, whatever, and it's been developed for a particular purpose and it's used in particular ways within that purpose, but for now we're just going to pretend that we're dealing with a function. So what E is the actual number. E is 2.58 or something or other. What is it? Let's just have a look. I've forgotten. 2.71828. Kind of like a pi, that's its value. But what it actually does is it does two things. So that's actually e to the power of 1. We don't write the 1, therefore it's e. Okay? The function of e looks like this. 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x 4 over 4 factorial plus ... And that function there, when you put 1 in, comes out with 2.71828. Now, why I've told you this, so if you don't know what 2 factorial is, 2 factorial means 2 times 1. So that one is 2. 3 factorial is 3 times 2 times 1. So that's 6. 4 factorial, 4 times 3 times 2 times 1. That is 24, etc. Okay? What happens here is that's just a polynomial. And if we differentiate that, so dy by dx of e to the x is equal to 1 disappears. All right, so that becomes 0. X becomes 1. Take the power, multiply by it. So I've got 2 over 2 plus x. That's become x. Take the power, multiply by it. 3x over 6. So what's that? 3x, take them over 1. So that's equal to x squared over 2, which is this one. So what do you think this one is? Yep, you're right. Cubed over 24. So 4 over 24 is 1 over 6. So this one equals x cubed over 6, which is the same as this one. So all it's done is move along. So what am I saying here? E to the x differentiates to e to the x. So you're given a table in the book, but what it says is that e to the x, ax I think it says, is a e to the ax. All right, so it's differentiating it, but we've got to remember the chain rule. So that bit there's just about the chain rule. Okay, all right, so I'm going to push pause. Okay, so if we use this for an example now and say y equals e to the 3x, it differentiates to dy by dx equals, take the power, that part there, 3e to the 3x. All right, not anything more difficult than that. If that part there is a function, then we have to do the chain rule. So one more example. If we've got y equals 5e to the 3x squared over 2, all right, then we rewrite it, 5 over 2, e to the 3x squared, and we differentiate it using the chain rule. So we've got 5 over 2. So that 5 over 2 is just a constant. If we have 5 over 2 of these things in the question, we will have 5 over 2 of these things in the answer. So it's easy just to leave that as a 5 over 2 in the beginning. Then we take this, differentiates to itself. All right, so no difference at all. And then in a bracket afterwards, we differentiate the power. So 2 times 3 is 6x. Now, in the answers, they're going to prettify it, but again, you don't need to. It's just that. It's quite a good idea actually to put this part in a bracket as well, so that you've got all 3 parts in brackets. So your constant, e to the x differentiates to e to the x, and the chain rule to get the other part of it. All right, so the questions I'm going to set for you have easyish ones like this, but they also include the product rule and the quotient rule in some of the questions. Sweet. Have a good time. Bye.